Hi guys, welcome back to the channel. This is the first video in our series called ML Projects for Beginners. In this series, we will learn machine learning by building real-world projects step by step. Today, we are starting with a very classic and beginner-friendly problem, house price prediction using linear regression. The best part is, we will use a dataset that comes directly from Python itself, so you don't need to download any CSV files. Let's get started. First, let's import the basic libraries we'll need. We are using NumPy for numerical calculations, pandas to work with data in a tabular format, and matplotlib to visualize our data using graphs. These three libraries form the foundation of almost every machine learning project in Python. Now let's load our dataset. We are using the California housing dataset, which is provided directly by the scikit-learn library. This dataset contains real housing data like income, house age, number of rooms, and the median house value. By setting as frame equals true, we'll get the data in a pandas data frame, which makes analysis and visualization much easier. Before jumping into modeling, it's important to understand our data. We first look at the top few rows to see what the data looks like. Then we'll check the structure of the dataset to understand the number of rows, columns, and the data types. We also use a statistical summary to see the range and distribution of values. From this, we can see that all the columns are numerical and there are no missing values, which means the data is already clean and ready to use. Now let's do some basic EDA. We start by visualizing the distribution of house prices to understand how the target variable is spread. Then, we plot the relationship between median income and house price. From this scatter plot, we can clearly see that as income increases, house prices also tend to increase. This kind of linear relationship gives us a good hint that linear regression can work well for all this problem. Now let's talk about why we are using linear regression for this problem. The main reason is that the value we are trying to predict, the house price, is a continuous number, not a category. Linear regression is specifically designed for this kind of problem. Also, when we look at the relationship between features like income and house price, we can clearly see a roughly linear trend, which makes linear regression a very suitable starting model. Another important advantage is that this model is very easy to interpret. We can understand how each feature affects the final prediction. Since this is our first project in the series, linear regression helps us focus on understanding the core machine learning workflow without adding unnecessary complexity. That's why it's best model to start with. Now we separate our data into input features and a target variable. All the columns except the house price become our input features, and the house price itself becomes the target we want to predict. 80% is the training set and 20% is a testing set. Test underscore size equals 0.2 means 20% of the testing. And random state 42 ensures same split every time. So it prevents overfitting and checks real performance. Now we create the linear regression model and train it using the training data. During this step, the model learns the relationship between the input features and the house prices by finding the best fit line through the data. Linear regression creates model object. Dot fit learns the relationship between x and y. It internally calculates the best fit line. Once the model is trained, we use it to make prediction on the test data. These predicted values represent the house prices estimated by our model for unseen data points. To evaluate the model, we use three common regression metrics. Mean absolute error tells us the average difference between the actual and the predicted prices. Root mean squared error penalizes larger mistakes more heavily, giving us a better sense of serious prediction errors. And finally, the R squared score tells us how well our model explains the variation in house prices. Together, these metrics gives us a clear picture of how well the model is performing. Finally, we visualize the actual prices versus the predicted prices. If our model were perfect, all the points would lie on a straight diagonal line. This plot helps us visually understand how close our predictions are to the real values. So that's it for our first machine learning project on linear regression. In this video, we understood the data, performed basic analysis, built a regression model, and evaluated its performance step by step. In the next video, we'll continue this series and move into more models, including classification algorithms. If you found this video helpful, make sure to like and subscribe so you don't miss the next episode. I'll see you in the next one.